All right, I'm going to end my a brief discussion of Chapter 3, or kind of lecture material of Chapter 3, with just a couple of questions, conceptual questions, which I always find interesting. And so, question 1. So, an electric fan is turned on in a room with all the doors and windows closed. The temperature of the room will increase, decrease, remain the same, or we need more information. Okay. So, you know, it's interesting because oftentimes we think of a fan as cooling us off, right? And the reason for that is the fan helps circulate the air um, in my room. Okay, but if I think about this from a thermodynamic standpoint, a first law of balance, all right? So we're in a room with all the doors and windows closed, right? So we have some closed system, right? Or I'm going to take my system to be my room, right? And so my system is closed. Okay, and then I have this fan, right? So I don't know. Here's my terrible picture of a fan. Okay, well the fan, right, is powered by electricity, right? So here now, right, I have energy entering my system in the form of electricity, right? So if energy is being added to my system, right, and energy is going to be conserved, since energy is being added to my system in the form of electricity, my room is closed, right? Then the temperature has to increase, right? Because energy is entering my system, and so temperature of my system, or energy of my system, is going to increase. The temperature of my room will increase. Okay, cool. And so it's kind of a cool problem to think about. It's a first law energy balance, right? Electricity is entering this closed system, so the energy of my system is increasing, and so we'd find that temperature would increase. Right? On the same note, so we have a refrigerator door is open in a kitchen with all the doors and windows closed. The kitchen temperature will increase, decrease, remain the same. We need more information, right? On a hot summer day, have you ever opened up your refrigerator door and just enjoyed that cold air, right? And so one thought might be, I leave my fridge open in the summer, my room's going to cool off, right? But it's not. You have to think of it from a first law balance again. So if I have my room, I'm taking my room to be my system, and here's my fridge, right? It's just like the fan, or my fridge is powered by electricity. All right, so I have energy entering my system in the form of electricity. All that energy that enters my system remains in my system. Okay, so all that energy that enters my system remains in my system. And so the temperature of my system, or the energy of my system, is going to increase, and so the temperature is going to increase as well. Okay, it's kind of cool, right? And we'll talk later on about things like air conditioners, but notice, well, if you were to go to the back of your fridge is hot, right? Because that's where all the heat that's being removed from. So if you take your fridge to be your system, right? So if you look at your fridge, you take your fridge to be your system, you're removing heat, right, from your fridge, right? You're imparting work to remove heat from your fridge. All right, so the back of your fridge is hot, right? That's all the heat that's being expelled. So if you think about your house in the summer with your air conditioner running like a refrigerator, right? Notice if you take your house to be your system, outside, right? That's where your air conditioner condensing coil should be, right? So the heat that's being expelled is outside. It's outside your system. Your fridge, right? Your fridge, the entire unit is inside, right? And so that heat is just being shot out the back. Okay, so some fun thought exercises. Hope you enjoy them. We'll see you soon.